Good morning everybody, my name is Ferhan Mazher and today is 7th of October 2020 and the day is Wednesday. Right now I'm in the 10 metric class and the subject we are studying is Physics 5054. So let's start. Today we are starting a new chapter and that chapter is basically that chapter is basically, the name of the chapter is Electrostatics. You see, every material in the world is made of atoms. And in a neutral atom, we always have a nucleus, and that nucleus has protons, and it also has neutrons. Okay? For example, if this represents a nucleus, for example, here I am trying to represent, just to make you understand, is that here I have a nucleus which has two protons and two neutrons. And there are electrons. And those electrons are orbiting around the nucleus. And they are, this is called electron, it's a negative, and suppose here electron. You see, every atom has nucleus. Inside the nucleus we have protons, we have neutrons, and outside the atom, outside the nucleus in the atom, we have electrons which are orbiting. Electrons which are orbiting around the nucleus. The protons, they have positive charge on them. And electrons, they have negative charge on them. So charge is basically of two kinds, positive charge, negative charge. The protons inside the nucleus, they have positive charge, and electrons which are in the orbits, that has negative charge. In the nucleus we also have neutrons. The neutrons don't have any kind of charge. So whenever you have an atom, naturally what will happen, the number of protons and number of electrons in an atom, they are naturally equal. If there are two protons in the nucleus, in the outer orbit, in the orbits, there will be two electrons. So the amount of positive charge and the amount of the negative charge is equal. So let's say here I have two positives and I also have two negatives. So they cancel out each other and the atom as a whole is neutral. But sometimes what happens, for example, you have taken out electron. For example, if you have an atom, suppose there are, let me show you an example. Suppose I have 4 protons. And there are, let's say, 3 neutrons. This is a nucleus. And there are, let's say, there are 4 electrons. So here I have electron, here I have electron, and there is another, and suppose here I have electron, and suppose here I have electron. Right now in this situation, in this atom, there are 4 protons, 4 electrons. 4 positive, 4 negative. So the positive and the negative, they are equal to each other, so it will be neutral. There are 4 positive, 4 negative. The electrons are negative charges. So it's neutral. But by some force or by some attraction, if you take out this electron, for example, if I take this electron out, look at this situation now. Now it has 4 protons and just 3 electrons. So now this atom will become a -1. Oh, sorry, a +1. Because now it has 4 protons but only 3 electrons. 4 positive but 3 negative. So it will become a +1. If it loses 2 electrons by any method, by any magic, by any trick, if it loses 2 electrons, suppose, so then it will become as +2. Okay? And other thing can happen. For example, this is right now neutral. By some method, by some magic, you bring an electron in this external orbit, another electron. Now you see what happened here. Now there are 5 electrons and just 4 protons. So this thing will become -1. Okay? Because now it has 5 negatives and only 4 positives. You see, when an ion is produced, the ion can be positive, the ion can be negative of an atom. The ion is produced by the giving or taking, donating or receiving of electron. The business of electron is done. You see, when I showed you the example that how a positive ion is produced or how a negative ion is produced, in both the cases, when the positive ion is produced, we give away electron. The atom gave away electron. And when the negative ion was produced, the electron was accepted by the atom. You see, whether positive ions are produced or negative ions are produced, the business of electrons is done. The electrons are given out or electrons are received. In both these cases, we never gave up protons. The protons are inside the nucleus. The positive protons, they are inside the nucleus. They are not given to anybody or not received by anybody. Whenever this electrostatic you study, it is never happening in your course that they gave protons to that atom, or this material gave proton to that atom. So whenever you will be describing the phenomena or any process, you never say that I gave protons. Or this material gave proton to that material. No. Or that this material received proton. No. That never happens. The business of protons is not done. Only the electrons are given. Only the electrons are received. If some object becomes positively charged, this means that it has lost electrons. If a material becomes negatively charged, it means it has gained electrons. So, electrons are given, electrons are received. If something becomes positive, it has lost electrons. If something becomes negative, it has gained electrons. So whenever you will be describing this chapter, you will be only writing that the electrons were transferred from this body to that body, or electrons are transferred from that body to this body. It's a very important sentence, because when people are describing this, sometimes the student, it starts writing that the protons were transferred. That do not happen. You understand? This basic idea, you understand? Okay. Another very interesting thing we can practice. If you have a plus plastic, if you have a plastic ruler, if you have a plastic ruler, and suppose this is a rod of plastic, or is a plastic ruler you have? Do you have, anybody has a plastic ruler? Okay. Then take small paper, piece of paper, small pieces of paper,
Then rub it on your hair.
and then rub this with your hair, if you have hair. So then rub this in your hair, the plastic, this is the plastic
Okay.
scale, and rub it in your hair. And then take small pieces of paper and put them on the top of a table. After rubbing it, bring this scale near to those papers. And you will see that those papers, they will be attracted to this.
Yes, sir. From the
They defying the gravity, they will jump and they will attach with the paper.
Yes, sir.
So you see, if you take this scale directly without rubbing to the top of on top of those papers, pieces of paper, they will be not attracted. They will be attracted only when you rub that plastic rod or scale in your hair, and then take it. Then it will attract those pieces of paper. You understand this?
Yes.
You might have done this at your home or during your previous classes. The basic reason is when you rub two insulating materials with each other. When you rub two insulating materials with each other, what happens? They both become charged. For example, when you rub a plastic scale against your hair, both are insulating. When you rub plastic scale with your hair, both hair and this, they will get charged. And they both will have opposite charge. For example, to make you understand this, for example, if you take a silk, what is a silk? If you take a silk cloth and you take a plastic rod, and you take a silk cloth, plastic rod, and you rub that plastic rod with the silk cloth, they both will become charged. Okay? Acha, when, for example, we can do an experiment. For example, take two plastic rods, rub them with the silk cloth, and suppose that both of them have negative charge on them. As is supposed to. I'm just supposing. When you rub it, it has a negative charge on them. So I took plastic rod. I rubbed it with the silk cloth. And the plastic rod will get charged, whether positive, negative. I suppose it's become negative. Take another plastic rod and rub it with the silk cloth, and obviously this rod will also become negative. Now you see, both the plastic rods are charged. Both the plastic rods are charged. Take a retort stand. Take a retort stand. This is the retort stand. And with the retort stand, we will have a clamp here. With that clamp, hang a thread, silk thread. And with that thread, hang this rod. This is negatively charged rod. Do you understand this diagram? What is happening here? Here I have a retort stand. And here with the help of thread, in this clamp, I have hung this plastic rod, one of them. And bring the second plastic rod here, near it. This is also negatively charged. This is rod A, this is rod B. Let me say this is A, this is B. So you see, when I will bring this rod B near the rod A, because both have the negative charge. Suppose both have the negative charge. I know this. They both have the same charge. So I'm supposing they both have the negative charge. So when you bring the rod B near the rod A, that rod A will start twisting. So for example, that rod A is hanging like this. Suppose it's hanging like this. When you bring the rod B near it, it will start twisting. Twisting. You will notice that these two rods are repelling each other. These two rods are repelling each other. You understand what I'm saying? The reason is, this is plastic rod, this is also plastic rod, this was rubbed with the silk cloth, this was also rubbed with the silk cloth. The idea is, whatever the charge is here, same the charge will be here. So they are repelling each other. The reason is because they both have the same charge on them. So it will move like this. When you try to bring it near it, it will run, it will twist, it will move away. So from here, a very basic concept, we make a conclusion. The same charges repel each other. The same charges repel each other. If you will have negative charged body and another negative charged body, if you try to bring them close to each other, they will repel each other. Like charges repel each other. Negative will repel each other. Positively charged body and the positively charged body will repel each other. So the same charges will repel each other. Okay, let's do another experiment. In that experiment, what we do, we take two rods, but both the rods are of different material. For example, I take a rod which is of plastic. Suppose it's made of plastic, and then I take another rod which is made of glass. So their material is different. And suppose I have both of them with the silk cloth. And I know that when something is rubbed, an insulating material is rubbed with the silk cloth, it will become charged. Suppose I know that the plastic becomes negatively charged and the glass rod becomes positively charged. Now take a retort stand. You know, you have seen the retort stand in your lab. Have you seen it?
Yes.
Okay. So we have, I will take the plastic retort stand, and here I have a thread. With that thread I have hung this plastic rod, and I suppose that the plastic is a negative charge on it. It's just a supposition, okay? And then I take that glass rod, which is rod B, and I think that it has opposite charge. I bring it near it. So when, let's say, this is that rod A, which is negatively charged, and this is rod B, which is positively charged. When you bring near it, it's hanging with a thread. They both attract. So this rod will start moving towards it. It will start attracting towards the rod B. Okay? You start twisting, but it will twist towards it. Rod B. From here, we make a conclusion that if both the rods, they have opposite charge on them, they attract each other. So, if the two bodies have the opposite charge on them, they will attract each other. If one body is positively charged, the other body is negatively charged, they will attract each other. So we say, like charges repel, unlike charges attract each other. So, do you understand what I was trying to tell you?
Yeah.
Okay. So, for the first activity, he says if we run the plastic comb through our hair and then bring it near small pieces of paper, the comb attracts them. Similarly, amber when rubbed with silk attracts the small pieces of paper. This property of attraction or repulsion between substances is due to the electrical charges they acquire during rubbing. We can produce electric charge by rubbing a neutral body with another neutral body. The following activity shows that we can produce two types of electric charges through the process of rubbing. Activity 13.1 is take a plastic rod, rub it with fur and suspend it horizontally by a silk thread. Now take another plastic rod and rub it with fur and bring it near to the suspended rod. We will observe that both the rods will repel each other. It means during the rubbing both the rods were charged. And activity 13.2 is now take a glass rod and rub it with silk and suspend it horizontally. When we bring the plastic rod rubbed with fur near to the suspended glass rod, we observe that both the rods attract each other. In the first activity, both rods are of plastic and both of them have been rubbed with fur. Therefore, we assume that charge on both would be of the same kind. In the second activity, rods are unlike and their attraction implies that charges on the two rods are not of the same kind but of opposite nature. These opposite charges are conventionally called positive charge and a negative charge. During the process of rubbing, negative charge is transferred from one object to another. From these activities we conclude charge is a basic property of material body due to which it attracts or repels another object. Friction produces two different types of charge on different materials such as glass and plastic. Like charges always repel each other, unlike charges always attract each other. Repulsion is the sure test of charge on a body. So I was reading this text from the book. So here in this case, you have a plastic rod and you rub it with fur in this first activity. Okay? In this second activity, I have a glass rod and a plastic rod, and the plastic rod was rubbed with the fur and the glass rod was rubbed with the silk cloth. Okay? So, according to your book, when I was trying to explain it, I used assumpted names, okay? And assumed name I used, but this is the exact wording which is in your book. So, I hope that you have understood today.
Sir, it was not included. Syllabus.
So, thank you very much everybody and have a good day. God bless you all.